Alright, today we're going to continue our discussion in inequalities. We're going to take it to the next level. But let's do a couple seconds of review here. First off, inequalities are things that are not equal. Equalities are equal things, equal. Inequalities are not equal. So I've put up a graph here. It says the price of an item that I buy my wife has to be greater than or equal to $10 so I don't get yelled at. So what does that mean? It means I can buy, P has to be equal to 10 or greater. Well, equal to 10 is easy. Boom, I can buy something that costs $10. Or I can buy something that costs more. And anything under my line, $11, $12, $13, $11.50, $11.52, $11.52 and a half cent, 11.537246, those would all be true here. But I can't buy something over at the store that's 11.52.36 cents beyond, or 11.5236. I can only buy things to the 100th place. So we have to talk a little bit here about domain, about where numbers are allowed to be. And our initial practice stays away from those type of situations and goes into some other things. And I'm going to use puppies to explain my idea. So if I wanted to buy a puppy for my family, P would have to be greater than or equal to 1. But my example here is, can I get a puppy and a half? I can. The Humane Society probably will call and complain. I have to either get 1 puppy, 2 puppies, 3 puppies, or 0 puppies. The point is my domain for puppies, my domain, I think, is positive integers. Can't be 0 if I'm going to get puppies. So how many puppies can I get? Well, I can get 1 puppy. What's the next integer to the right? 2 puppies. 3 puppies. And when I have the dots like this, it implies 4 puppies, 5 puppies. If I did this, it means I can only get 1, 2, or 3. But if I put the dot here, it means I can go on forever. So when I have puppies, I can't have 1.5 puppies, or 1.72 puppies, or 2.3 puppies. So my inequality is coupled with a domain. And often here, for practice sake, we give you the inequality in the domain and we ask you to graph it or to work backwards. Today we're going to just work that. The puppy loves math too, by the way. So I have some examples on the board just with the domains. I'm going to work my way around this way. Here I'm going to start up in this upper left corner. It says x is greater than 2. And remember, I always start on the variable because this could also be written this way. X is greater than 2. I read left to right or right to left. I start on the variable. X is greater than 2. So I know I have a number line with x. And if x is just greater than 2, I know it's everything to the right of 2. The question is, what numbers? Well, I have set a domain of all reals. That means it's everything. So it's not equal, so it's an open circle, and it's everything to the right. Very much like we've been doing. Everything we've been doing up to this point has been this domain. Well, let's take a look at the next one over here. It says x is not greater or equal to 3. If it's not greater and it's not equal, the only thing left is that x is less than 3. So I make my number line. Now less than 3 is to the left, but it's not all numbers. I have to check the domain. Now right now, if this was reals, you'd put an open circle and you would point to the left. So now I need to put some numbers on my number line because the domain is not reals. Well, it's all integers, so I put the integers on the board, and it's not equal to 3, so it's open. I won't even put that on there. 2 is the first integer to the left of 3, then 1, then 0, then all the integers keep on going to the left. And this implies -1, -2. So again, I have graphed the domain, and I have graphed the inequality. This one, in the right corner. X is greater than or equal to 7, domain is real. So again, you don't have to worry about whether it's dots or not. X, 7, is it equal? Yes, so it's a filled in dot. That means X is equal to 7, and that's every number to the right. X is greater to the right. Finally, this situation. X is less than -1. Okay, and domain is positive integers. So I start to graph it. I know positive integers, so I put my integers on the board. Well, okay. If this was a real, we would just go and make an open circle on -1 and point to the left. X is less than -1. But it says it has to be positive. So what positive integers are to the left or are less than -1? There are no integers less than -1 that are positive. This is called a null set or a void set. So it's just no graph. There are no numbers that make this a true. So we have no options. Just like when they ask me for a puppy, there are no options. The domain for puppies at my house now is 0. So you ask for a puppy, you don't get a puppy. Alright, we'll tie this together to some of the other things here. Domain, the additive property of inequalities along with the domain. We're going to go with reals first. But this is a case where we put something with the variable. Alright, so the battery died. I put a new battery in the camera. We're talking about the additive properties of inequalities. And we always get the variable by itself. We always say x is greater than, x is less than. But here it says x plus 7 is greater than 3. And we really can't handle that. We're going to work through examples. I have to get the x alone. And just like equations, whatever I do to one side of an inequality, I must do it to another. So I will start by making this minus 7. And say, hey, x is greater than 3 minus 7 is -4. Well, now I have domain of reals, all numbers, and x is greater than -4. So I make my number line, -4, open circle because it's not equal, and it's everything greater is to the right. Now I should be clear when we have conjunctions, and we're used to this. Remember that x plus 1 is greater than or equal to 3, and x plus 1 is less than 5. We have put two inequalities on the board just written as a conjunction to be lazy. So when I subtract the 1 here, there's two things to do. This is one equation, and then I have this one over here, which means I have to subtract 1. And it looks like we're doing it in 3 places, but we're actually balancing just two inequalities in one place. 2 is less than or equal to x, which is less than 4. Again, if we stick with the domain of reals, we have 2, we have 4, solid dot for equal to 2, open dot, and we have this. And again, not too hard, but we have to get the inequalities alone, the x variable alone, and we have to get the domain picked out after the fact. So, if I start here and work around again, x plus 2 is less than 0 for a domain of reals. Well, first thing I better do is subtract the 2 on both sides. X is less than -2 for reals. Alright, well we have x, -2. And we have to go to the left. So, the left, less than is to the left. Over here we have x minus 3 is not less than 5. Well, that means x minus 3 is greater than or equal to 5. The other two trichotomy signs. It's either greater, less, or equal. Those are only 3 choices. If it's not less, it's those 2. Again, we'll add 3, and I get x is greater than or equal to 8. I will start setting up for this and say, 8, but it's not reals, it's integers. So I will give myself some integer marks. And I'll start here. X is equal to 8. Boom. 1 dot. X is greater than 8. What's the next integer greater than 8? Well, 9. 10. Does it go on forever? Sure does, so I leave it like that. And since the dots doesn't show 11 to stop it, it means it goes forever. If I showed the 11 with no dot, that would mean just 8, 9, 10. Now it means 8, 9, 10, 11, 12, 13, 14, 15, and so on. Finally, x is not less than or equal to 2, so x is greater than 2 for positive integers. So I'll move this up here. X is greater than 2. So there's 2. Well, there's 1 and 0. 3, 4. So it's not equal, so it's open circle. So I could put that on if I wanted, I suppose, open circle. What's the next integer greater than 2? Well, 3, 4, and 5, 6, and so forth. And again, if I show 5, this would just imply 3 and 4. Okay? This would be something like this. But since that's not on there, put a dot, and it implies it goes forever. Last one. X is not greater than 4. Well, if it's not greater, it's less than or equal to 4. domain of reals. So again, this is an easier case, all things. So here's 4. It's equal to 4, big solid dot. Less than is to the left. Again, inequalities in domain. It's whether or not you're counting all numbers or maybe you're counting puppies, but it just takes some practice.